Session 6.3 Trigonometric Equations. For these sessions, we're gonna learn how to solve the equation with half angles and with multiple angles. Let's look at this example. Solving an equation with a half angle. We have a 2 sine x over 2 equal to 1. And given that x is in between 0 to 2 pi. Now we are calculating the half angle. So we need to calculate the interval. We're gonna divide it by 2. So you're gonna get x over 2 is always in between 0 to pi. Now we're gonna isolate the sine x over 2 here. So we want to divide it by 2 for both sides. What is the reference angle of sine when it's equal to 1/2? You could look at the special triangle. So reference angle x over 2 will be equal to pi over 6. And since this is a positive, so the angle has to be in quadrant 1 and quadrant 2. So quadrant 1 reference angle will be equal to the angle, which is gonna be pi over 6. Okay, and then we want to calculate the x, so we're gonna multiply by 2 for both sides. We do have the first solution, x equal to pi over 3. And then quadrant 2, reference angle equal to pi over 6. So we do have the x over 2 equal to pi minus pi over 6. Okay, remember that reference angle in the quadrant 2. So if we want to find out the angle, we're gonna subtract from the pi. Get the same denominator. You should get x over 2 equal to 5 pi over 6. And then we're gonna multiply by 2 for both sides. So you have x equal to 5 pi over 3. So we do have the solution set pi over 3 and 5 pi over 3. Okay, the same questions, but this time that will be finding for all solutions. Okay, for all solutions means we don't have the restriction in here. Okay, we're gonna do the same thing. We divide it by 2 for both sides. Find out the reference angle. Okay, just like the part A here. Now, that will be in quadrant 1 and quadrant 2 again. So quadrant 1, the angle will be equal to pi over 6 plus 2n pi. Okay, 2 pi means you're gonna go for one circle, and it's a positive integer. When n equal to 0, then you do have a first solution, pi over 6. When n equal to 1, means you're gonna go for one circle. When n equal to 2, then you're gonna go for 2 circles. So this is called all solutions. And we are not done yet. We are looking for the x, not x over 2, right? So we're gonna multiply by 2 for the whole equation. So times 2 here, you're gonna simplify it, you're gonna get pi over 3. Times 2 here, you're gonna get 4n pi. Okay, how about the quadrant 2? We're gonna do the same thing. The angle will be equal to pi minus pi over 6. So this is gonna be pi minus the reference angle. And then since we are looking for all solutions, so we're gonna add 2n pi again. So this one, get the same denominator, you're gonna get 5 pi over 6. And then we're gonna multiply by 2 for the whole equation. So you do have the solution set, x equal to pi over 3 plus 4n pi, and then 5 pi over 3 plus 4n pi, where n is any integer. Okay, example 2, solving an equation using a double angle identity. So cosine 2x equal to cosine x over the interval from 0 to 2 pi. So we're gonna apply the double angle formula, right? Cosine 2x, we do have a free formula, remember that? So I will choose the cosine 1 because we do have the cosine x in here. Now I subtract the cosine x for both sides. So this is a quadratic equations, right? Ax squared plus bx plus c equal to 0. I want you guys try to factor out this guy. Okay, you should get this. And then zero product property. I separate into two equations. So let's solve this guy. We're going to subtract 1 for both sides and then divide it by 2. Okay, what is the reference angle when cosine x equal to -1/2? The negative tell us the angle will be in the quadrant 2 and quadrant 3. And the reference angle will be pi over 3. So in the quadrant 2, the x will be pi minus pi over 3, which is 2 pi over 3. Quadrant 3, reference angle is pi over 3, so x will be equal to pi plus pi over 3, which is 4 pi over 3. Okay, this part here, so cosine x equal to 1. And then when x equal to 0, cosine is going to be equal to 1. And then cosine 2 pi is also equal to 1, but over the interval, x cannot be equal to 2 pi. So we only have a one solution this part. So solution set will be 0, 2 pi over 3, and 4 pi over 3. Okay, example 3. Solving an equation using a multi-angle identity. We do have a 4 sine theta cosine theta equal to rect 3. And then the theta will be in the interval from 0 to 360. Okay, this one, do you guys still remember the formula? I could break down with the 4. So I have a 2 times 2 sine theta cosine theta. What is a 2 sine theta cosine theta equal to? That will be sine 2 theta. Okay, and then we're going to divide it by 2 for both sides. And since the theta will be in between 0 to 360, now we do have a 2 theta. So we're going to calculate the interval. Okay, we're going to times 2 here. So 2 theta will be starting from 0 until 720 degrees. Okay, there's a 2 circle. Now we're going to calculate the reference angle, which is going to be 60 degrees. Sine 2 theta will be equal to positive rect 3 over 2. So positive for sine, that will be quadrant 1 and quadrant 2. Okay, for quadrant 1, my reference angle will be 60 degrees. Okay? But this is talking about the 2 theta. And then the 2 theta, that is from 0 to 720 degrees. Okay? So the quadrant 1, the first angle, that will be 60 degrees. And then we could keep adding on it. We're going to go one more here. So the second angle will be 60 plus 360, which is 420 degrees. And then we could keep adding on it. So when we have a 420, we could add one more circle here. Okay, so you do have a 420 plus 360. But for this one, this is already 780 degrees, which is exit the solutions. So we only have these two angles, which is gonna be 60 and 420. Now we want to find out the theta, so we're gonna divide it by 2 for the whole equation here. You're gonna get 30 and 210. Okay, how about the quadrant 2 here? Quadrant 2, talking about the reference angle for 2 theta, which is 60 degree, will be here. So first, let's calculate it. Okay, so theta, 2 theta will be equal to 180 minus the reference angle, which is going to be 120 degree. So that will be the first solution, right? And then second one, we could add the 360 again. So the second one, 2 theta, will be 120 plus 360. And that will be 480 degree. Okay, so that's the second solution. And then after we have the 480, we could add one more circle here. So 2 theta equal to 480 plus 360. And then obviously, this is going to be greater than 720. Right? So we could ignore this one. Okay. So you should have 120 and 480. And then we're going to divide it by 2 for the whole thing here. So this is going to be my solution set. Okay, B. Same questions, but this time the data will be for all solutions. So we're going to do the same thing, just like the previous slide here. We're going to get sine 2 theta equal to rho 3 over 2. Same idea, reference angle will be 60 degree. And then quadrant 1 and quadrant 2. So quadrant 1, I will have 2 theta equal to 60 degree plus 360 degree n. And n is a positive integer. Okay, when n equal to 0, we only have a 60 degree. When n equal to 1, we do have a 420 degree, just like the question A here. Okay, and then we put the n. When n equal to 2, you're going to add it up. Now, we're going to divide it by 2 for the whole equation. Okay, quadrant 2. So we do have a 2 theta equal to 120. We're going to use 180 minus the reference angle. And then plus 360 degree n. Divided by 2 for the whole equation. So this is going to be my solution set. And n is an integer. Okay, example 4. Solving an equation with a multiple angle. We do have a tangent 3x plus secant 3x equal to 2 over the interval from 0 to 2 pi. So we do have a tangent and we have the secant here. Okay, so what we're gonna do? I'm gonna subtract secant 3x for both sides. Now, I want to take square for both sides. Okay, after you take square, you should get 4 minus 4 secant 3x plus secant square 3x. And then, since we do have a secant here, so we try to convert the tangent to the secant. Remember the formula? You should have a tangent square theta plus 1 equal to secant square theta. Okay, so tangent square theta will be equal to secant square theta minus 1. Okay, just like this guy here. And then we're going to simplify it. So we cancel out the secant square 3x. We're only left with these 3 guys. Combine the 9 terms. Okay, divided by 4 for both sides. And we try to convert it to the cosine. Okay, so reciprocal of 5 over 4, that will be equal to cosine 3x. Okay, keep going. So cosine 3x and x is from 0 to 2 pi. Now we do have a 3x. So we're gonna multiply by 3. And then we're gonna calculate the reference angle using the calculator. Okay, make sure you guys convert your calculator to radian. Okay. Cosine 3x is gonna be positive. So we have a quadrant 1 and quadrant 4. Okay, let me explain this part here. So we have the quadrant 1, reference angle, the 3x will be equal to 0.6435. Okay, so quadrant 1, somewhere like here, 0.6435. Okay, we are working on the 3x. So 3x, that would be from 0 to 6 pi here. So this is going to be my first solution. Okay, the first solution, 3x equal to 0.6435. And then since 3x, we could go to the 6 pi. So what we're going to do, we're going to add 2 pi here. Okay, plus 2 pi. So that's why we do have the second one, 0.6435 plus 2 pi. And then we could add one more circle here, adding another 2 pi. So that would be 0.6435 plus 4 pi. Okay, if we're gonna add 2 more pi, that will be more than 6 pi. Okay, so we're gonna just stop here. So that's why we do have this guy. And then we're gonna divide it by 3 for the whole equation. So you should get this 3 answer. That's only talking about the quadrant 1 here. Okay? Okay, cosine positive. This is a quadrant 1. Another one will be in the quadrant 4. Okay, quadrant 4. So the reference angle will be here, 0.6435. Right? So you know, this is my first solution. We're going to use the 2 pi minus 0.6435. Right? And then there's 2 ways to do it. You could just finding out this answer and then adding another 2 pi. Okay, or what I'm gonna do, since I know this is a 2 pi, it's a 360 degree, right? And then another 2 pi will be 4 pi. So I'm gonna do the same thing, 4 pi minus 0.6435. Oh, this is a 5. And then the interval for the 3x can go for the 6 pi. So I have one more, 3x equal to 6 pi minus 0.435 here. And that's why I'm gonna get in these two. Okay, here you could get one more, like plus another 2 pi here. Now I'm gonna use the calculator, take care of this. You should get this number. Okay, I didn't divide it by 3 yet. And then I'm gonna divide it by 3 for each of the solution. So this is gonna be my solution set. Okay, 1, 2, 3, 4, 5, 6, 6 answer. That's it.